Now theorem 5.6 says that if both pairs, this pair and this pair, are congruent, one pair is congruent, another pair is congruent. So two pairs are congruent. If both pairs of opposite angles are congruent, then it's a parallelogram. So let's prove that. So the statement, reason, and so angle A congruent to angle C, angle B congruent to angle D is given, and we know that, from work we've already done about the angles of a polygon, that these will all add up to 360, right? So angle A plus angle B plus angle C plus angle D is 360. Okay, and that's because the interior angles add up to n minus 2 times 180. Remember, since n is 4 here, we have 4 minus 2 times 180, and that'd be 360. But notice that we can put A and B in place of C and D, because A and C are the same, and B and D are the same. So in place of this C, I can put an A. And then I can put a B. That's substitution. But then we have two A's and two B's. So we just added. Then we can divide by 2. That's just division. So angle A and B are 180, but notice these are same side interior. When same side interior are supplementary, the lines are parallel. Okay, so we know that AD is parallel to BC. When same side interior angles are supplementary, it implies parallelism. Okay, but we're given that these two are congruent, so these also must be supplementary. Angle A plus angle D is 180. Substitution, and therefore AB and DC are parallel. Now I'll erase this and write it up here. So AB and DC. Okay, and then since these are parallel and these are parallel, we know by definition that ABCD is a parallelogram. by definition of a parallelogram. All right, done. That's theorem 5.6. Now the next one. So theorem 5.7 says that if the diagonals of a quadrilateral bisect each other, so AC cuts BD in half, and BD cuts AC in half, so you see AO equals OC, and BO equals DO. If that's the case, then it's a parallelogram. So this is pretty straightforward to prove. Remember, to show it's a parallelogram, we need to use one of our theorems already, or use a definition of parallelogram. I'll go ahead and use a theorem to be different about kind of how you've proved things so far. Now, if we use theorem 5.4, if this is equal to this, AB to DC, and if AD equals BC, and you can look at the theorem, then this will be a parallelogram. So we need to try to prove that. And we can do that by showing triangles are congruent. So notice that this is the same as that. So by side, angle, side, a pair of sides, a pair of angles, and a pair of sides, these triangles are congruent, and therefore these are congruent. On the other hand, these are also vertical angles. So by side, angle, side, a pair of sides, a pair of angles, a pair of sides, these triangles are congruent, top and bottom, and so that this is equal to this by CP/CTC. So then by theorem 5.4, it's a parallelogram. Okay, so let's work that out. So we have our given, and then we know that 1, 2, 3, 4, angle 1 is congruent to angle 2. I'll just call it the vertical angle congruence theorem. So therefore, by side, angle, side, we know triangle, put that O back in here, AOD is congruent to triangle COD side angle side theorem, and therefore AD is congruent to BC by CB/CTC. And then we can look at the top and bottom triangles, and so angle 3 is congruent to angle 4 by the vertical angle congruence theorem again, because these are opposite angles. You see we got two lines, and these angles are congruent. And then by side, angle, side, this pair of sides, this pair of angles, this pair of sides, we know that AOB triangle is congruent to COD side angle side theorem again, and therefore AB and DC are congruent. And so opposite sides are congruent, so by theorem 5.4, ABCD is a parallelogram. Done. All right. So let's try a few exercises next.